Alright, this next part is a little trickier. This is where we're dividing radicals and rationalizing denominators. Okay? So you want to rationalize the denominator when you have radicals in the denominator. Okay, so for example, for part A, I have this right here. Alright, this is called a monomial denominator. So all you do when you have this situation is multiply the numerator and the denominator by the radical. So my radical, the problem radical is the square root of 3x cubed. Alright. So, going to multiply like we did in the previous example. 216 times 3 is 648. x5 times x cubed is x8. All divided by 2x. Alright, now when I multiply two of the same radical, the radical disappears. So I can get rid of that, and I'm just left with what was underneath the radical, 3x cubed. Okay, so time to simplify. So on top I have 648. Let's see if I can break this down at all. So 648. Go back to my perfect squares. Now, I'm going to see what I have. So 648. I'm trying 81. And this gives me 81 and 8. So that's a perfect square, so I can leave that. And then get 8, which is 4 and 2. So this is nice. So 648 is really 81 times 4 times 2. So on top, square root of 81 times square root of 4 times square root of 2 times square root of x to the 8. And on bottom, we got 2 times 3, which is 6. X times x cubed is x to the 4. We get 9 times 2 times square root of 2 times x to the 4. All divided by 6x to the 4. Alright, clean it up. 9 times 2 is 18. X to the 4, square root of 2. 6x to the 4. Alright, well, I can simplify this. Alright. So 18 divided by 6 is 3 on top. And x4 over x4 cancels out. So I'm left with 2. So my final answer after all this crazy amount of work is 3 square roots of 2. Okay. B. I'm going to just try and simplify my fraction first. So the cubed root of 288 divided by 2, which is 144. x7 over x squared is x5. y4 over y, which is y cubed. Right? Okay, that looks good. Now I got to break these up. 144. So we're looking for cubes, perfect cubes. So let me see. Got 2 cubed is 8. Let's try 8. 144 divided by 8 is 8 and 18. There's no more perfect cubes that go into 18. Okay. Then I have x5. So I need to make this divisible by 3. So let me put x cubed in front here. So to make 5 is x squared. And then y cubed is fine. So I got cubed root of 8, cubed root of 18, cubed root, cubed root, cubed root. So cubed root of 8 is 2. Can't do anything with 18. Times x times cubed root of x squared times y. 2xy on the outside. On the inside, I got 18 times x squared. And that's it. Looks good. Now, this next part can be very difficult. This is where you have a binomial denominator. So you need to multiply by the conjugate. All right, the conjugate is the bottom, but the sign is flipped. All right, so let me zoom in. Okay, so this is the bottom, which is the problem. So we can't have square roots in the denominator. So what I need to do is multiply by the conjugate. So the conjugate is the same thing except for this changes to positive. Okay. So on the top, I'm going to do 1 plus square root of 5. And on the bottom, 1 plus square root of 5. So, FOIL where I can, distribute where I can. 4 times 1 is 4. 4 times square root of 5 is 4 square roots of 5. On the bottom, we're going to FOIL. So 1 times 1 is 1. 1 times square root of 5 is positive square root of 5. Minus square root of 5. And then remember, square roots, when they're the same, multiply together, all that's left is what's on the inside. So minus 5. Alright, so over here, I always forget the end of my screen is all blotchy. So equals, top doesn't change. Over, so the 1, the inside cancels. Minus 5. One more cleanup. 4 plus 4 square root of 5 over negative 4. Alright, well, I lied. There's another cleanup, because if you look at the triangle here, it's not really a triangle, but those 3 numbers, they're all divisible by the same. So I'm going to simplify one more time. All those numbers, their greatest common factor is 4, or negative 4. So if I factor out negative 4 from all of them, I'm going to get negative 1 minus the square root of 5. And that is the final answer. Alright, and D, same thing, just there's a binomial on top and bottom. So the conjugate, okay, square root of 5, 4, square root of 5, and 4. So it's plus right there, so the conjugate of the plus means it's minus. Okay. FOIL on the top and the bottom, so it's going to be kind of crazy. So I'm going to get 3 square root of 5 minus 12. Then we have, I'll use a different color for the other part. 5 and 5 gives me plus 5. Square root of 5 times negative 4 is negative 4 square root of 5. To the bottom, square root of 5 square root of 5 is 5. Negative 4 square root of 5. And we got positive 4 square root of 5. Now the reason why we do the conjugate here, I don't know if you noticed between both examples, is this middle part right there cancels out. Middle part cancels out. Okay? That's why we do the conjugate. It forces those radicals to cancel out. And 4 times negative 4 is negative 16. I'm going to clean up my mayhems. I'm going to combine like terms on top. 3 minus 4 gives me negative square root of 5. And then negative 12 plus 5 is negative 7. And then down here, the middle, they cancel out. So 5 minus 16 is negative 11. And that's it. Well, they're all negatives. Technically, if you want to be super motivated, you can do square root of 5 plus 7 over 11, since they're all negative.